Hi everyone, in this video we will take examples of section formula for vectors. The idea behind this video is to give you a lot of hands-on practice on problems which come directly in JEE, and these problems relate to the topic of section formula which was introduced in the last video. So if you are unfamiliar with section formula, please check out that video. So what are these kind of questions which come in JEE? And these questions which come in JEE are typically a set pattern. That is, you can learn what to do in these problems, and once you know them, it is pretty straightforward to do these problems. In the next part of this video, towards the later part of this video, I will actually like to give you a very quick, very easy shortcut to these problems, something that I learned while doing these problems, and I realized that okay, there is a set pattern, and actually rather than solving all of these things by your hand, you can very quickly do these problems rather than trying to solve them through the long route. So first I'll take two problems and I'll go through a long route, and then I'll quickly generalize the pattern, and hopefully that will be enough for you to understand how to do these problems. Again, the idea is to give you a good understanding of how to approach these problems. I really strongly believe that in mathematics, rather than solving too many problems, the more important thing is to really understand different kinds of problems and different approaches. Once you understand these approaches and these problems, it is pretty straightforward for you to solve the problems. Okay, so let me start by first taking an example. The kind of questions which generally come in section formula are like this. Generally they have a triangle. It is not necessarily that they will have a triangle, but generally they will have a triangle. And today I'll just be talking about triangles. There are very few problems of some other geometries, but they may exist. So let us start with what are the problems which we see in triangle. And the problem says that if you have a point D, if you have a triangle A, and you have been given position vectors, again anything with relating to a point is position vector. We have extensively covered in the last two videos about what is position vector, and we have been told that the ratio in which D divides BE is 2:3, and the ratio in which E divides AC is also 2:3. And we have been asked to find what are the relationship, and this G vector is given by G, small g vector. What is the relationship between G vector and A, B, C vectors? Also, in what ratio does G divide AD and BE? This is a very classical example of section formula, and if you know how to solve this problem, it is very easy to solve this problem. Otherwise it could be pretty complicated, and you may even have trouble just starting the problem up. So the way to think about this problem is to first write what we already know. So we know one thing is we know how to write the coordinates of D. So let us call this as D vector, and let us call this as E vector. So we know that we can write the coordinates of D vector as 2C vector plus 3B vector. We have covered this in the last video, and then 2 plus 3, or nothing but 2C vector plus 3B vector by 5. Okay. Similarly, we also know that E vector is 2C vector plus 3A vector by 2 plus 3, or 2C vector plus 3A vector by 5. Okay. Now, what is our task? Our task is to find the G vector. So how to find G vector is our question. So we know one thing, that G vector lies on the line AD as well as line AB. So in other words, you have to find some combination of xa vector plus yd vector right? G vector would be some x a vector plus y d vector. For instance, D vector is some x a vector plus y x c vector plus y b vector, because it lies on B C. It is some factor of C plus some factor of B. Okay, and what is the ratio? Is 2:3, but it is some factor of C plus some factor of B. Similarly, E vector is some factor of C plus some factor of A. Now we have to find G vector. G vector is a point on line AD, so it has to be some factor of D plus some factor of A. Similarly, it has to be some factor of B plus some factor of E. Okay, so we can write G as in two ways. For what I am trying to say is G could be xd plus x1d plus y1a, right? And G vector could also be x2b plus y2e, right? And we also know that whatever G vector comes out in these two cases has to be same, right? This has to be equal. This has to be equal because G is the same point, right? Now here comes the trick. Here comes the trick is that what we can do is we can also write these equations. We can write these equations like this: 5D vector is equal to 2C vector plus 3B vector. Similarly, 5E vector is equal to 2C vector plus 3A vector. And now what we have to do is we have to add something into A here and something into B here, such that these two things become same, because then that would be actually the value of some times D vector. For instance, what I am trying to say here is if I add 3A vector here and 3B vector here, this means that this is same, right? And in other words, and if I divide by the sum of these, which is 8 here and by 8 here, then this would actually become G vector. And why? How can I be sure that this is G vector? So what I did was I added something in the relation with D, and I added some factor of A. I added some factor of A such that also becomes equal to the quantity to which I add some factor of B into this relation of BE. And then I divided by the sum of the numerators, so that this becomes the section formula. So let us go step by step. What does 3A plus 5D by 8 mean? It means a point dividing A and D in the ratio 3:5. So in other words, that this is 5 and this is 3. Similarly, this means that this is something, a point in BE which divides this line BE in 3:5. This is 3 and this is 5, such that the coordinates are this and this is same. Because this is same, this means it is the point on both the lines, right? Because this is the same position and hence this is G vector. I hope that this makes sense. So basically there are 3 steps. So let's just remember 3 steps. First step is that you write relations of section formula. Okay. In the second step, you add something to the right hand side onto this side, such that basically you multiply first, make it 5D and so on, and then you add some factor of the opposite point such that this and these two quantities become same, and then you make it equal to G vector. So I hope that this made some sense to you. If it is a little difficult, it's fine. We'll take another example and then that will hopefully clarify a few things. Okay, so let us take an example quickly, second example quickly. Okay, so what is the second example? The second example is that this is exactly the same. So we have A vector, we have B vector, we have C vector here, then we have D, we have E, and the ratio in which it divides is this is 3:1, this is 2:1, and we have been asked to find the G vector like in the last problem, okay, in terms of A, B and C, and then we have been asked to find the ratios. So we will start again. What we'll do is first step is to write the section formula relations, and I'll do it a little quickly in the sense that I will not divide by 3. So what I'm trying to say is I'll write that 2c vector plus a vector, 2c vector plus b vector, 2c vector plus b vector is equal to 3d vector. I hope it makes sense. Rather than dividing by 3 here, I just took it here. Similarly, I'll write 4e vector is 3c vector plus a vector. Right? Now what do I have to do? What I have to do here is that I have to add some factor of a here and some factor of b here, such that these two quantities become same. So I can add some factor of a here and some factor of b here. So I cannot add any factor of c here, but because I want to add some factor of a here and some factor of b here, I have to make sure that the factor of c is same in both the equations. In here, because the c only had 2c in both the sides, I could directly add 3a and 3b. But here, I just cannot add a and b here, because first I have to make sure that 2c and 3c are also same. So what I'll do is I'll multiply this by 3 and multiply this by 2, and I'll write 9d and 8e, and this is 6c plus 3b, and I'll write 6c plus 2a. Right, now I can make both sides same by adding 2a here and 3b here and 2a here and 3b here. So this is the second step. This is the second step. And then divide by 2 plus 9, which is 11, and by 11, by 11, and by 11, and this is equal to g. Okay. And what is the ratio in which g divides AD? So 2 here, 9 here, and 3 here, and 8 here. Okay. So can you see a pattern? Can you see a pattern? I don't know if you are able to spot it very quickly, but what is happening is that if you can find this g vector, the ratio in which AD is divided is this 2 comes with A, and the remaining 6 plus 3 comes here, 9. 3 comes here, and then 6 plus 2 comes here. So in other words, if I were to make a line here, F, right, and if I wanted to see how is this F divides A and B, then I can look at the coefficients of A and B. Okay, I can look at the coefficients of A and B. So 2 is multiplied with A, so it will be farther from A, and then 3 is multiplied with B, so it will be like 2:3 here. And if I want to find the ratio of this point, then I should look first for C. What is the factor of C? C is 6 here, this is 6, and this is 5. I don't know if it is too complicated for you to understand just in the first step what I am saying here, but now I'll make it general, which I hope would be useful and would make things much easier. So this could take some time to digest, but I understand that, but I hope you are able to see some pattern. So let me try to make a general rule which will hopefully help you very, very easily solve this problem. General rule, okay. So let us take a problem here. Okay. So let us say I have been given some ratio here, What I will do is I will always make it 1:x. I'll force it to become 1:x, so that I'll make a coefficient of C as 1. Okay. Then here also I'll force it to make it 1:y. I will talk about what I mean by that. Then I will write g vector directly as c vector plus xb vector plus ya vector by 1 plus x plus y. Okay, I'll talk about this, so just write it down for as a this, that you can make this ratio as 1:x, this ratio as 1:y, and then you should be able to write g vector directly as this. Ag is to gd would be equal to y into 1 plus x, y is to 1 plus x, bg into ge would be equal to x into 1 plus y, and if I make a line from here c to g and which goes here as f, then cg into gf would be equal to 1 is to x plus y. Okay, coordinates of f, because that is something which I have not discussed till now. Coordinates of x would be xb plus ya by x plus y. Okay, so there is a lot of information here. This is the general rule that I have given you, and you can very quickly learn how to do this, what I did here, and I'll clearly write like example 1 here, question 1, and I'll treat x and y here. Question 2, I'll write x and y here, and then you can see whether this actually works or not. So what I did here is that I said that I will force this c vector ratio to become 1 in both the cases, 1 is to c. So I can write d vector as x times b plus 1 times c into some x plus 1, and then here 1 into c plus c into plus y, 1 into c plus y into a, and then all I need to do is I just need to add this third vector, because c vector has the same, like in this problem c vector had the same coefficient. In this case factor I made c forcefully 1, and because I did that, I can just directly add all these three values, xb plus c plus ya, and then add the coefficient 1 plus x plus y. Then ag is to gd can be found by first looking at the coefficient of a, which is y, and then adding 1 plus x. bg into ge can be looked at coefficient of b, which is x, into remaining 1 plus y. Similarly, coefficient of cg can be looked at coefficient of c1 into ratio of 1 x plus y. Okay, and finally f vector can be looked at the relative ratios of b and a, which is xb plus ya by x plus y. So let us try what this problem means for question 1. And then let us let the shortcut approach. Okay, shortcut approach. So what does x mean in this case? X mean in this case I want to make it 1, so x would become 3 by 2, right, and y would become 3 by 2 also, because I want to make this to be 1, so I'll just divide it by here, so it will become 3 by 2. And can I make what is the value of g? G vector is c plus 3 by 2 b to b plus 3 by 2 c by 1 plus 3 by 2 plus 3 by 2, and if you actually solve this, this will become 3 by 2 plus 3 by a here, 3 by 2a, this will become 2c plus 3b plus 3a by 8. Okay, you can try to do this and it will come out to be same, which is very good because you could just directly do this and write the whole answer here. Similarly, if I take problem 2 here, x would be what? X would be 1 by 2 and y would be 1 by 3. Okay, and if we want to write g vector, that would be c vector plus half c vector plus half b vector plus 1 by 3 a vector by 1 plus 1 by 2 plus 1 by 3, and if you do if you simplify this will become 6c vector plus 3b vector plus 2a vector by 11. Okay, so you are actually able to do this exactly in one step and directly able to get to the answer which you were actually doing a lot of steps through. You are taking a lot of steps to do that. So now, as a homework, I have given you a very general formula. However, more than the formula, I hope you are able to learn the approach. Please try to do this very slowly, and then you will be able to understand that what I mean by section formula. It's not a very easy concept to understand, but think about it, that first you just write d and e, and then you are trying to add some coefficient of a into d and some coefficient of b into e, such that this value becomes the same, because if this value becomes the same, then that means it is the intersection of AD and BE, and which is nothing but G. Once you understand that, try this problem in which we forcefully made the coefficient of C's to be the same, and because when we did that, then we can directly add the remaining values of A and B, and then you can get the answers of G. And after that, try to derive this yourself, a general formula yourself, by using 1 and x and using the entire this approach or this approach, and then you can actually find that this works. So please take out time, even if it means that you are doing it for multiple hours. It will be really helpful for you if you can really understand this well enough. As homework, what I would suggest is try to find the coordinates of centroid, which means the ratio is 1:1:1. Then in center is the intersection of angle bisectors, and there is an angle bisector theorem that can give you the ratios, as like BD is to DC ratio is same as AB is to AC ratio. That can help you find the coordinates of in center. Again, you just use the general formula and you can be able to do that. Then you can also try orthocenter, which is the intersection of perpendiculars, and then finally you can try circumcenter also. Once you are able to do that, you will actually be able to do a span of questions with this general formula, and you will be able to tackle any problem that comes which is similar to this. So I hope that this part was useful, and I have tried to give you actually just a general formula for all the kind of problems that will come which are similar to this. So I hope that this video was useful. In the next video, we will go on to multiplication of vectors, which will mean dot products and cross products. So I hope that you will check out the next video, and thank you for listening. Thank you.